as the Laue's method is to be there. Now if you look at this diagram, this gives you systematically what exactly is to be there. And if you look at, I am closing little bit this much to understand it carefully. So look at this arrangement is nothing but to be as good as your spectrometer is to be there. And if you look at this case where it is to be as, and this is what the collimator part is to be there, where this is what to be as an goniometer, which is called our prism table. And here it is nothing but to be a screen or whatever be the your eye telescope is to be there. Here the film is to be used, a photographic film is going to be used. Two photographic films are going to be used in here for the pattern for of the crystal is to be there. And this is what the exactly arrangement is to be there, or the setup for the your Laue's method is to be there, to get the Laue's pattern or how these wavelets are going to be work exactly. Now here the beam or the collimator is to be having arranged in such a fashion that it is to be as an having the pinhole, that is it is very small as far as the collimator point is to be there. It is a pinhole is to be there. And if you look at here, it is to be there. And from this pinhole the x-rays are coming of nearly 0.2 to 2 angstrom, that is 10 raised to minus 10 meter, and 10 raised to minus 8 centimeters are to be there. That is angstrom unit, you can say 1 angstrom is to be there. Now in this case, when the beam of x-ray is going to be incident here through this collimator, where it is to be as an collimator having the pinhole, and through this this is a goniometer or the prism table, you can say. And here is the crystal, which crystal you wants to find out the uh, three-dimensional way atoms are going to be arranged in that case. And when the x-ray beam is going to be incident on this particular layer, then the diffracted and the reflected rays are the reinforcement of the atoms are to be there, and this reflected and diffracted beams are to be generated in this case, and which will give you nothing but to be the Laue's pattern is to be there. And here this is what the setup, complete setup for the your Laue's method is to be there. And here if you look at this secondary film pattern where it is going to be formed. Now as far as the how it is to be the Laue's method, why there is this Laue's method is going to be used for the X-ray refraction or the Laue's pattern is to be there. To understand that, first we have to understand what is mean by to be as in your Laue's pattern is to be there. The Laue's is name is nothing but to be comes from the scientist, the Laue's who first invented this part. That's why he has given this particularly pattern as an Laue's pattern is to be there. As far as this part, already we have seen in the X-ray diffraction case where the Laue's pattern or reinforcement of the secondary wavelet is to be there. As far as the Huygens principle, we are also aware about that. And after reaching certain light wavelets, it works as an secondary wavelets are to be there. In the same fashion here to be as an this X-ray beam, when it is going to be incident, this is what the A is nothing but to be distance between the two atoms are to be there. And this is lambda is nothing but the path difference between the layers or the atoms arrangement in this. As far as the three-dimensional case where the atom is going to be concerned, we are aware about that the part is nothing but to be where we can say, as far as solid is going to be concerned, we know that it is always in the three-dimensional. And in this case where the layers are to be there, these layers path difference is nothing but to be given with here to be as an your lambda is to be there. As far as interatomic distances, distance between these atoms are nothing but to be given with a small a. And if you look at these wavelets, when it is going to be incident as an crest part, and the diffraction will be there from these atoms at that point, but it is not in the same direction or a perpendicular direction, but it is also the diffraction is in it is in the another directions also. And due to that the reflected parts are to be where it is to be as an there, the two things wherever the part is to be there, as the X-ray beam is going to be incident on the such type of the atoms, or it works to be as an vibrated with the same frequency as that of the incident wavelengths are to be there. And due to that it will works to be as an it will vibrate, or it will also generate with the same frequency vibration. It will vibrate with the same wavelength, we can say, as far as these atoms are going to be concerned. Now this is where these points or the atoms works as a secondary wavelets are to be there, and that's why it works to be as an your reinforcement of the wavelets are to be there. म्हणजे ह्या ॲटम्सला, ह्या ॲटम्सवर जे काही एक्स रे बीम पडायला, त्यामुळे ह्याच्यामध्ये जे काही व्हायब्रेशन जनरेट व्हायला ते सिमिलर टू द एक्स रे बीम एवढंच त्या पार्टनी व्हायब्रेट व्हायला लागले, त्या सेम वेवलेंथनी. आणि ते स्वतःसुद्धा त्याच वेवलेंथनी जेव्हा एमिट करू लागले रॅडिएशन, त्यामुळे रिइन्फोर्समेंट ही जी काही आहे त्या वेवलेट त्या ॲटम्सला वर्कआउट करायला लावली, रिइन्फोर्स करायला लावली, त्या पद्धतीने व्हायब्रेट होण्यासाठी, त्या सेम वेवलेंथनी व्हायब्रेट होण्यासाठी. दॅट रिइन्फोर्समेंट मीन्स नथिंग बट टू बी लाउस पॅटर्न इज टू बी देअर, and it is as not in the one direction or the perpendicular direction, and due to that we will see the different zeroth order, first order, or the second order is to be there definitely, which is exactly at the center, which will call to be as an zeroth order. And the first one right hand, it will be the first order, this one will be right hand side, this is to be second order. In the same way as it is to be zeroth, this one will be the first, and this one will be the second order is to be there. And this is what the Laue pattern is to be there. This is what the Laue method is to be there to understand this X-ray diffraction pattern, or the Laue pattern is to be there. So as far as Laue method is going to be concerned, we are aware about that. To produce the Laue pattern, this method is going to be established for that case. As far as we already discussed in this part, that the flat plate camera with the collimator, the previous what we have already discussed, to obtain collimator is to be there, and from that collimator the fine beam is going to be of the X-ray is going to be insert, and to obtain the fine beam from that collimator. And there are the sample crystal which from the X-rays where you wants to incident, that sample crystal is to be taken on the goniometer, that is at the center we have seen. And at the end, the screen or the film, the two flat photographic films are placed. And these two, why there is two flat photographic films are to be there, one will be for the receiving the transmitted diffracted beam, and the another one will be reflected diffracted beam is to be there. As we are aware about that X-ray diffraction condition, or sorry, Bragg's diffraction condition, there is a diffraction as well as the reflection interference is to be there, and due to that diffraction and the interference, they are going to be counter interchangeable in this X-ray, or the diffraction pattern, or the Bragg's conditions is to be there, that we have seen in detail in previous session. So this is what the arrangement for the Laue method we have seen. As far as the dimensional part is to be concerned, what exactly the particularly the crystal dimensions are to be there. Basically the crystal of very tiny size, that is 1 into 1 into 1, that is length, breadth, and the height will be 1 mm is to be there commonly for that crystal is to be there, that such a tiny crystal is taken into account. And as far as X-ray beam of particularly having the wavelength of nearly 0.2 to 2 angstrom unit is going to be inserted or through that collimator beam, and which is going to be incident on the your crystal, whatever the sample crystal you have taken. And the diffraction production with the no doubt Bragg's condition is to be there, and the diffraction spots will be produced on the your whatever be the your photographic films are to be there. And the crystal is rotated by the goniometer, which is at the center, and by rotating the different patterns you will find for the diffraction conditions are to be there. And the diffraction condition is going to be satisfied for the diffracted atomic planes are to be there for the different planes, as we know that the crystals are, or the solids are made up of with the different planes, it is nothing but to be a sets of planes are to be there. And due to that, when you are rotating this crystal, you will find the diffraction condition of the Bragg's for the different layers, sets of the planes are to be there, and that will give you the film, the pattern on the film is to be there, what type of the pattern or the symmetry is going to be there as far as that crystal is going to be concerned. And this is what the diffraction pattern will be obtained on this your photographic films are to be there. and due to this you will find what exactly the patterns are going to be there, or what type of the unit cell is going to be there. So Lau's method is basically used to find or to determine the crystal symmetries to be there when you are putting this particularly X-ray beam on that your crystal having the 1 into 1 into 1 mm size, and the nearly 2 angstrom unit beam is going to be X-ray beam is going to be incident. And as far as the for an example to determine the crystal symmetry, that nothing but to be, as suppose one crystal is having the fourfold axial symmetries to be there, definitely Lau's pattern will show exhibit the same pattern, fourfold symmetry will be on the your film, definitely you will find. And this pattern will helps to find out the shapes of the unit cell. Due to this pattern you will find exactly what type of the shape of the unit cell is to be there. Again, this pattern, again the condition is that this pattern is not practical to find out the determine or to determine the exactly the crystal structure, because what is the case, as the not the size part, but the whatever the beam is going to be incident, the wavelength is going to be coincide with the one center point. And as the variation for that particular beam is going to be the whatever the wavelength variation part is to be there, it is coincide at one point, and due to that it is very difficult to get practically as an structure for of that crystal is to be there. And that is what the limitation as far as the pattern is going to be describing this crystal structure is to be there. That's what it is not practicable to find out with this point, whatever the incident beam is to be there, what type of the crystal is going to be there, as the very tiny point is to be there and the beam is going to be incident. As this pattern is also helpful to orient the crystal for the various solid state physics experiments are to be there. Another very important factor using this Laus method is to determine the definitely as an imperfection in that crystals are to be there, or the strains in the crystals are to be there, and that will be definitely useful as far as the beam is when going to be incident. It will find out either there is any imperfection in the crystal is to be there. If there is any imperfection in that crystal is to be there, the curved planes will be found on the pattern, and that will streaks on the your Laus pattern will be curved pattern will be in found, you will on the your films are to be there. And such type of the pattern streak in the pattern will be called as a uh, asterism is to be there. And that type of the particular case will shows that there is a imperfection in the your crystal is to be there. And this is how the Laus method is to be useful for to determining the crystal symmetry as well as imperfection or the strain in that crystal is to be there, which is also useful to find out for the different solid state examples, or the experiments are also to be there. So this is what the one part of the Laus method is to be there. So thank you for being with me for this session, and